Well, hello, how are you today?
I'm fine, thanks.
Okay, that's great. Nice to see you again. Tell me, please, before we start, did you have any issues, any problems with your previous homework?
No, not at all.
Okay, nice to hear. Did you compare the answers that you got with correct answers at the bottom of the page?
Yes, I got everything right.
Oh, that's amazing. Look, it sounds great, and I'm very happy about your progress, very proud of you. And now you are officially proficient at limits. So that's great, and we will be moving forward. Today we will look at differentiation. It is the next chapter. Of course, it's directly related to limits, and very important chapter in math. In previous lessons, you solved a lot of problems of that kind. Limit f of x when x goes to a, and the result is some capital letter A. Can you please remind me about this small letter a? Is it a fixed number or maybe a variable?
It's fixed from the start.
Okay, yeah, of course, it's some number that we fix at the very beginning. And what about this capital letter A? Is it a fixed number at the end or maybe also some variable?
It is a fixed number.
Of course, it's also a fixed number. And tell me about x. Does it vary or is it fixed?
It changes.
Yes, of course, it's a variable. It varies, it changes. And the same we can say, of course, about f of x. It also changes and it varies, variable. So it was our previous cases. F of x could be some fraction, some function, some expression. But now we'll have very similar situation. We have a function. Let's write it down again as f of x is a function. X again is our variable. And we also fix some number a. Number a again is fixed, and we will call it again as point a. Point a. But now we will look at another limit. Please pay attention and write down what I'm writing now. Limit when x goes to a, and here we have a fraction. On the top we have f of x minus f of a, and on the bottom we have x minus a. Okay, x minus a. Perfect. So please tell me, does it look confusing to you? Does this expression looks complicated for you?
No, not at all.
Great. So for some people it looks confusing. That's great that it's simple for you. But in order to write it in a more simple way, we will say the next thing. This one on the bottom, difference x minus a, we call it increment of x, and we usually denote it as delta x. Let's write it down here. Delta x, by definition, is x minus a, and we call it increment of x. Increment of x. Increment of x. And you can also write it as at a point A, at a point A. Perfect. And the same one for the expression on the top in numerator. The difference f of x minus f of a, we call it increment of what?
Of f.
Yeah, of course. Delta f, by definition, is f of x minus f of a, and we call it increment of f. Increment of f, and again you can add at a point a, at a point a, if you wish, but in a short way you can say it increment of x, increment of f. This sort of notation, what does it give us? It gives us that we can write it very concisely. We can write it in a very short way. It would be just delta f over delta x. Okay, is it clear for you?
Yes.
So with these new definitions?
Yes, absolutely.
Yeah, perfect. So of course, my main advice to you is that you should remember this initial form, because it is very detailed and it's the most helpful for you. That you have a limit when x goes to a, f of x minus f of a on the top and x minus a on the bottom. It is the best way to remember it, but it's very often that you have expressions in books, in different problems of that kind, that delta f over delta x. And if you have this expression, you should always remember that delta f is f of x minus f of a, not inversely, not f of a minus f of x. Some people just, confuse it. So you should remember exactly what is delta f and what is delta x. That is this difference. Is it clear? Perfect. Okay, and if you can calculate this limit, if it exists, then the value of this limit is, we denote it as f prime of a. And this value is actually called the derivative of f at a point A. It is derivative of f at a point A. Perfect. So A is our point that we initially fixed, and f is our function. Does it look difficult for you? Is everything clear?
Yeah.
Yeah, perfect. So you can see by what we wrote here that we have not a lot of information, right? So in order for you to get used to this new definition, let's write, very simple examples. Let's take the situation when f of x is a constant function. For example, situation number 1. Let's assume that f of x is a constant function, like constant. And my main question for you, let's assume that we fixed some number a. What would be the derivative of f at a certain point a?
Let's use the definition.
Yeah, exactly. We should write it by definition. So we should write like limit x goes to a, and please direct me what should I write on the top here.
F of x minus
Yes,
f of
exactly.
a.
F of x minus f of a. And on the bottom,
X minus a.
Great. And tell me, please, what would be here on the top? Because we have a constant function. What would be f of x when f of x is always a constant function c?
It equals c.
Okay, it would be c, yeah? C minus f of a, what would be?
Also c.
Also c, yes. And here x minus a. So in this fraction on the top, in numerator, what do we have? C minus c, it is?
0.
Yes, and the value of this limit is?
0.
0. Okay, so what is our conclusion here? Our conclusion is if f of x is a constant function, then f prime of a is always 0. Perfect, at any point a. It is our first example, very simple one, right? Perfect, let's go to the second example. A little bit more difficult. F of x equals x. What would be, if we fix some point a, what would be f prime of a here?
Let's write the formula.
Okay, again, limit. For our convenience, let's write it again. Not a problem for us. F of x minus
F of a.
yes, and x minus a. Again, please guide me. What should I write here? Limit x goes to a. Okay, f of x, instead of f of x, what should I write? It's
X.
yes, exactly. X minus f of a is
A.
yes, and here x minus a. What is the value of such limit?
1.
Perfect, 1. Okay, and our conclusion, if f of x equals x, then f prime of a equals 1 for any a. Well, that's great. Let's go to the third example. Okay, the third example is f of x equals x squared. Let's again fix some number a. What would be f prime of a in this case? Again, let's write this limit. We are only starting. There is no need for us to really skip this step. F of x minus f of a, x minus a. Great. Please direct me. What should I write here? What should I write?
It would be x squared minus a squared.
Limit x goes to a. Okay. X squared minus a squared, x minus a. Well, as you are a talented student, can you tell me what would be kind of, the ratio? Can you simplify this fraction?
It equals x plus a.
Okay, that's great. Well, I knew that you will tell me correct answer. X plus a, perfect. And the value of such limit is 2a, perfect, 2a. So it is our result. Let's draw our conclusion. And our conclusion in this case is if f of x equals x squared, then f prime of a equals 2 A. Amazing. So as you can see now, we went through 3 different examples here. We started from just definition, and we had very simple kind of steps, very simple examples. So of course I will save this paper and I will send it to you. But let's draw a general conclusion. In our case, it will be the conclusion of the next kind. If we have a function, some function f of x, okay? What we can do? We can fix different points a, b, c, d. And at each point, at the point A, we can calculate the value f prime of A, okay? At the point B, we can calculate f prime of B. At the point C, we can calculate
f prime of C.
f prime of C. At the point D, f prime of D. So at every point, we can calculate its own derivative, okay? Assume that all of them exist, you know, we can calculate these limits. What can we say then? We can say then that f prime is actually a separate function, that f prime is a separate entity, separate function. Because what we say about f prime, it is defined at the point A, it is defined at the point B, at the point C, at the point D, and so on. So basically we can speak about the function f prime of x. It is a new function, okay? Also a function. It's a very important thing for us. So it's not just a limit at a certain point A. You can look at this f prime x as a separate function. Of course, you need to have initially some function f, and after that you can figure out what is this function. We'll go in detail later, but is it idea clear for you that if we can figure out derivative at one point, at another point, at a point, then the derivative f itself is also kind of, you know, an independent function?
Yes, sure, I understand.
Okay, perfect. So because in mathematics, usually we say that there is initial function f of x, and after that we can derive its derivative, another function f prime of x. And how it would look initially. For example, if I want to calculate the derivative of f at some point A, it is exactly the value, it is the same as the value of a function f prime of x at a point A. So please tell me, it's important thing, it's very simple, but some students have issues with this idea. Is it clear for you that we can look at the derivative as a separate function?
Yes, like on a new function.
Yeah, that's amazing. That's amazing. So, and let's go to our previous examples that we had earlier. So, in this case, when f of x is a constant function, the derivative, what is the function of the derivative?
Total zero function.
Yeah, exactly. It is a zero function. So, in this case, then we can say that f prime of x is actually a zero function. It's always zero. Okay, and if f of x is x, we say that derivative at some point A is 1. What would be the general derivative function here? F prime of x?
It always equals 1.
Yes, it's always 1. Perfect, always 1. And the last one, a little bit more sophisticated. If f of x is x squared, we fixed arbitrary point A and figured out that it would be 2a, the derivative is 2a. What would it be the derivative in general case? F prime of x would be...
A bit difficult to say.
I will help you, 2x. 2x. Is it clear? Because a, substitute here a, it would be 2a.
Ah,
okay?
ok.
So it is the initial thing. Okay, so it is our initial page. So I will save it and I will send it for you. Of course, I'm also recording now our lesson because we are going to a little bit sophisticated stuff. I will send you also video recording. But let's look at the rules of working with derivatives. Usually, what you do now, you will not do in the exam because we just work with definition. In exam, you will work with derivatives that you basically already know. All the elementary functions that we work with, they already have well-known derivatives. For example, now we have went through the example like this one. Derivative of a constant function is 0, okay? Okay, so we have a partial case of here. General case is when x to the power of alpha, in our case alpha equals 2, and if you substitute here 2, you will have x to the power of 2 prime, and we already calculated that it would be 2x. If you substitute in this formula alpha equals 2, it would be 2 times x to the power 2 minus 1. It would be exactly what we got in our case, but there is a more general formula. You shouldn't be scared about kind of big amount of these expressions. You actually don't need it, especially for our first lessons. The only thing that you will need is only these formulas from this corner, okay? If you differentiate sine x at any point, you will get the same as cosine x. So does it look difficult for you?
Well, not really.
Yeah, perfect. So these are pretty simple formulas. You should remember it. And I will tell you a little bit more in detail, but let's go to very practical things that you will use in exam. So when you have, for example, derivative, at first you denote derivative in this way. Whether you write f prime of x, it's the one way, or another way you can say df over dx. It is also writing that is also typical for derivative. These are the same things, okay? It is both denotions of derivative. It's both derivative, okay?
Yes.
Derivatives. And before we start going to some practical examples, I will show you very simple rules that are very helpful for working with derivatives. For example, if you have sum of functions, you have f of x plus g of x, okay? And let's assume that you want to get a derivative at a certain point a of this sum. Do you guess what would it be? Can you take actually the derivative of each separate function instead of...
I assume so.
Yeah, of course. So there is a formula that derivative of sum of functions, it is actually the derivative of one function plus derivative of another function. So, and of course, if there is a minus here, f of x minus g of x, it would be minus here. So derivative of sum of a difference is it can be written like this one. It's very clear. Just remember this formula and another formula, very important. If we have some constant number k times f of x, and we want to take the derivative of this expression. So can we kind of, put constant k here?
I think we can.
Yeah, again, you are right. Okay, we can write it like this: k times derivative of f of x. So you can see here we have very, very simple rules. But for example, if we have a multiplication of functions, f of x times g of x, and we want to take a derivative of this product, it would be a little bit more complicated. You just cannot write that it is f prime of x times g prime of x. You should remember the next formula. I will not go in very detailed way to explain, how it works, and so you should remember for your exam the certain formula f prime of x times g of x plus g prime of x times f of x. So these are the formulas that we will use today to solve different examples. There are several more, but in general there are just a couple more formulas, and this is it. You will not need to remember much of them. Tell me please, which of these formulas look complicated for you?
The third one.
Yeah, of course, this one, because it's not the simplest one, but these are simple, right?
Yes, of course.
Yeah, perfect. So we will use this one. You know, when you go to the university, you will have very clear understanding of what is it, but basically derivative of a product of functions, you should remember that you can calculate it in this way. Derivative of a product equals derivative of one function times the other plus derivative of the other function times the first one. So it is just now we will use this formula. It's very simple again to remember. And let's go to some practical examples from our edXL book. So we will go to the page 61